a smart thing to do. I mean, if I just give you the answers, you might as well just write them down. So everybody should have your books open. So this is chapter 3, section 4, and we're still talking about multiplication. And in this section, they're going over not multiplying with one number, but with two numbers. So in this first example here, it says a ferry carried 37 cars per trip on the weekend. If the ferry made 11 trips on Saturday and 13 trips on Sunday, how many cars did it carry in the weekend? So here are the numbers that we're multiplying, and it's going to be 37 times 24. And look what they've done here in this chart right here, okay? They broke it down into the tens and the ones, 30 and a 7, and then did it again, the tens and the ones, a 20 and a 4. And so what they did is they first looked at what's 20 times 30, okay? 20 times 30. Then they looked at 20 times 7. Then they looked at 4 times 30, and then 4 times 7. And then right down here, they just added up the answers for each. And that's definitely one way you guys could do that. Let me move this up. That convinced me what are ways you can estimate to check reasonableness of the answer. Well, and so at least one student was confused in the last section. They estimated, and I'll say it again for this one. They just want you to check your answer by estimating. They're not asking you to estimate as that's your answer. So 37 times 24, if I wanted to estimate that, instead of 37, Miss Gage, what number might you pick instead of 37? Instead of 37, what number might you pick if you wanted to estimate? No, don't look at her. What, honey? What number, counting by tens, is 37 close to? Start counting up. 37, 38, 39. What's next? I'll wait because it's being recorded. All you got to do is answer. The shyness, sorry. 40, yes, nicely done, 40. That's all you got to do is say it. Now I'm going to ask you the same thing about 24. There's a couple of different ones you could pick, but I'd be happy with either one. What number is 24 close to, counting by 5s or 10s that you could use as an estimate? I think you're making it harder than it is. Say again, huh? Well, it's already 24, so that won't work. So we're going to estimate. We want something that's close to 24. Okay, no, I want her to say it. Look at me and answer the question. What do you think? Say again? You said 34, not 34. So we want something close to 24. Look at me, hon. Counting by 5s or 10s. So 10, 20, whoops. 10, I'll get it here. 10, 20, 30. That would be your choices counting by 10. So we can count by 5s. 5, 10, 15, 20, 25, okay? So look at those numbers that I just wrote down. What is 24 closest to out of those numbers? Speak up. It's close to 30. Yeah, it's closer to another number still. I'm going to scratch out 30 because 30 is not it. We're talking about 24. What is 24 closest to out of all these numbers? Yeah, 25, exactly. 25. So, whoops, I put 24. 25. So 25 times 40, or you could have picked 40 and 20. That also would have worked as an estimate, okay? All right. So what are ways you can estimate to check your reasonableness of your answer? So we just went over that. You guys can phrase that in your own words. I'm not going to bother to write that down here, okay? So let's continue on looking at this. All right, I'm moving down. I'm going to the next page here. Looking at number 1. So Janet said that the standard algorithm is just a shortcut for partial products. The standard algorithm is a shortcut for partial products. I would say yes. Are they asking us to explain that? I'll just say yes. And we'll leave it at that. We'll leave it at that. So let's look at this one here, number 2. It's 41 times 23. 41 times 23. And you can see what they've done here. Here's the 40 and here's the 1. Okay? And here's the 20 and here's the 3. And they just broke it down. So I'm not worried about number 2. What they want you to do is to fill in these boxes, and I'm not worried about that. You don't need to do that. So let's move down a little further. I'm looking at number 3, and it's kind of the same thing. They're having you fill out some boxes. What I just wanted to do this. Let me cut this out here to make sure you guys understand what they're doing. So I'm going to just pull this over here and make it a little bit bigger so everybody can see it. Here's what they're doing. So this area here would be 20. Actually, that's hard to read. I'll do black. It'll be 20 times 10. So 20 times 10 equals something. And then in the purple area, that looks like it's going to be 20 times 6. And so I'll put that here. 20 times 6 equals something. And then in that little narrow blue area, down at the bottom here, that's going to be 2 times 10. And so that would be 2 times 10 equals something. And then finally in that little tiny green area at the bottom right, that's going to be 2 times 6. 2 times 6 equals something. And then you would just total those up. You would just add them up. And if that's easier for you to do it that way, you are welcome to, if it helps you understand that. So you're multiplying the two tens placed together, then you're multiplying one of the tens placed times the ones place, and then finally the ones, and then in the blue, the ones times the tens place, and then finally the ones times the ones place. Okay? Yes?
So do we have to fill the boxes in?
Yeah, in these here, in 3, 4, 5, and 6, I do want you to fill out the boxes. I wasn't worried about it with the first one, but in those I would like you to. Now, I'm looking at number 5 here, and they've got the blank boxes around this colored rectangle. So I'm going to look at this first number here, 27. What do you think would go in this box right here? Let me pull a stick. And look at the two boxes up above that. Look at 3 and 4. That might kind of help you out. Mr. Ramirez, what do you think would go in that box right there?
10.
Yeah, exactly. So in this first box is a 20. What do you think goes in the one right next to it, in this one right here? We did the 10s in the 27. What's next? Right here. We're doing 27. We did the 20s. What's left? Say it. 7. Okay, that's 27. All right, now we're going to do 12. Okay, so put up 10 points. Mr. Delgado, I'm looking at number 12. What do you think goes in this first box right here?
10.
Yep, 10. What do you think goes in the box below it? 2. So you guys can also do that with number 6. I did number 5 for you. Of course, 7, 8, 9, 10, 11, 12, 13, 14. Solve them any way you choose. Questions on this so far, you guys?
No.
Yeah.
What is the box called? The little rectangle?
I would call it a little rectangle. I don't know. I don't know what else it's called.
I thought it was called an area model. Just Daniel
Called a what?
area model. Area model.
An area model. Okay, yeah, I like that. And I think you're probably right. I guess it would be an area model. Yes, question? Yeah, put up your points. You bet. An area model. When I start thinking of area, yeah, it would be length times width, and so that would be a good choice. Okay, number 15. Let's look at that really quick. I'm on the problem-solving page, the next page. It says the Queen Mary II's height above water is about the same as a 14-story building. What is the Queen Mary II's height above water? So here's the information you need that they gave you. Each story is 12 feet tall, and it's about the same as a 14-story building. So I'll be looking for that answer. And number 16, write the multiplication equation illustrated by the array drawn on the grid. Find the partial products and calculate the final product. Well, in this one, it's kind of hard to see. So, let me give you a hint here. I had to look in my book because I can't quite read it in this. So they've got 14 times 19. 14 times 19. And then they have 10 times 10. I guess one of the grids is 10 times 10. And then they've got a 10 times 9 and a 4 times 10. 10 times 9 and a 4 times 10. And so, yeah, so the 14 times 19, this right here is the entire grid. That's all of this. Then they broke it down into 10 times 10, 10 times 9, 4 times 10. Am I missing any here? 10 times 9, 10 times 10. So I've got 1, 2, 3, 4. 4 times 9. I think I'm missing one here. A 4 times 10. Yeah, I'm missing a 4 times 10. 4, no, I got a 4 times 10. Why, I count, let me see here. 1, 2, 3, 4. 10 times 10.
You're missing the 9 times 4.
Well, they've got a 4. Oh, yeah, you're right. Thank you. Nicely done. Put up 20 points. And then a 4 times 9. So if you did each one of these right here, you would get the total for that entire grid. So you would add up those 4 that I've highlighted in green. Actually, on that screen, it almost looks blue. It looks like it's the same color. Let me circle it. Add up 1, 2, 3, those 4, and then you'll have that whole model. Okay. 17, an elevator can carry 15 adults or 20 children at one time during the course of a day. The elevator carries a full passenger load 52 times. So that's probably going to be important. If all the passengers were children, how many more people would the elevator carry than if all the passengers were adults? Okay, wow, that's a complicated question. Let's think about this. So it can carry 15 adults or 20 children at one time. And it carries a full passenger load 52 times. And then the question is, if all the passengers were children, so that's going to be 20 times 52 equals something. How many more would the elevator carry than if all the passengers were adults? And if they were all adults, it would be 15 times 52. So obviously it's going to carry more children than adults, and that's the question. How many more people would the elevator carry than if all the passengers were adults? Okay, so you need to figure out those two and then do some subtraction and see how much more. All right, almost 20 minutes. Let's see here. Last two, 18 and 19. You guys can do those on your own. Okay, so I'm going to end this video.